My name is Gadiel Sinditama, student ID 13118226. This video is made as a partial fulfillment for the subject MS 3200, Practicum Phenomena Dasar Mesin. I will present to you the experiment done to see the effect of humidity on falling objects. In this video, I will discuss the phenomena being observed in the experiment, the systematics of the apparatus and how it is used, then a practice run complete with its results, also analysis and suggestions on how to improve the apparatus. A falling object might have multiple forces acting on it. Some of them include weight, which is due to the gravity pulling on the object, causing it to accelerate downwards towards the ground. Then there is drag, which opposes the direction of acceleration. Drag, also known as air resistance, is affected by the properties of both the falling object and the fluid the object is falling in. This experiment is done to show whether the difference in humidity will affect the property of air enough to also affect the speed of acceleration of the falling object. In theory, humidity affects the mass of air in a certain volume, which also affects the density of the air. The change in air density correlates with the amount of drag acting on the falling object. This experiment must be done in a controlled area where we can vary the humidity. Varying the humidity of a large area will be a difficult, costly task. Instead, an apparatus will be made to accommodate the experiment. The apparatus will consist of an enclosed container connected to a humidifier used to raise the humidity inside it. A laser beam sensor will be embedded inside the container for us to be able to see the speed of the object falling inside the area past a certain distance. After price calculations and further observations, changes and adjustments are done to the plan to accommodate the budget and effectiveness. On the right, we can see the updated plan. The updated plan now uses one laser and LDR instead of a pair of each. It also removes the LCD display from the plan, reducing the price significantly, more suitable to the given budget, and then mirrors are used to bounce the laser beams to create two laser beams across the area where the object will be dropped. The Arduino will now be connected to a laptop or a PC, and we'll use a built-in monitor tool to see the time the object passes through the laser beams. This way we will be able to calculate the time needed for the object to travel. And then the falling object is now changed with a styro cube, since it has a bigger drag coefficient. The falling object is also replaced with a styrofoam cube. In this slide we can see the picture of the assembled apparatus. This is the falling object, which is a styrofoam cube with magnets on top. And on the right we can see the Arduino circuit. We can see here is the LDR, which connects to a trim-pot and then goes also connected to the Arduino. Here we can see the laser transmitter, which is embedded inside the container, the LDR, and then the humidifier connected by a hose to the container so that it can raise the humidity inside. And then here is a packet of silica gel to keep the humidity inside the container low when it is not in use. Then here again is the falling object, which is a styrofoam cube. Here's a picture of the hydrometer and its sensor embedded inside the container. And then here is a picture of the magnet trigger. It has magnets down here, which connects to the magnets attached on the cube, which holds the cube hovering on top of the area. Then when we want to start the experiment, this trigger will be pulled up and the object will be dropped. The experiment is done by following the steps below. First, pull out the silica gel, which is used to maintain a relatively low humidity inside the container. And then initialize the Arduino IDE program in the PC. Open the serial monitor tool from the Tools drop-down menu. After opening the tool, make sure that Auto Scroll and Show Timestamp are both checked. Next, check if the laser beam is aiming at the LDR. If not, adjust the mirror and make sure the laser beam is aiming at the LDR. And then read the measurement on the hydrometer attached right here. Note down the measurement as the low humidity test. Step 9. Insert the styro cube inside and attach it to the top of the apparatus by using the magnet trigger. When ready, slowly lift up the magnet trigger to release the cube. Make sure it falls down smoothly. If not, repeat the step. Immediately uncheck the auto scroll on the software. Look for the reading where the value drops down significantly. This shows when the cube passes or blocks the laser beam. There should be two different values where the reading drops significantly when the beam is obstructed first and second time by the cube. In this case, we can see here is this 84 and the value 80. And then take down note of the times and calculate the difference. Pull the block back up and reposition it ready for drop. Turn on the auto scroll feature in the software. Repeat the experiment to obtain more data. Next, turn on the humidifier, make sure the apparatus is sealed, and then watch the humidity reading on the hydrometer increase until the desired value. Note down the reading of the hydrometer as a high humidity test. Again, do the experiments 5 more times with a new humidity value, and then take averages of the two tests in different humidity. Observe the difference in the two values, if any, and then proceed to do data processing until the value of drag is obtained. Here are the equations used in this experiment. First, the equation used to calculate the drag, and then next the equation used to calculate the density of the air relative to the humidity, and then lastly the equation to calculate the velocity of the falling object across a certain area. We can see here the calculations of the two experiments done in different humidities. On the left side is the lower humidity, and on the right side the experiment with the higher humidity. First, we calculate for the velocity of the cube, and then we average the humidity values during the experiment, and then we move on to calculating the density of the air given the humidity, and then here we get the value of the drag coefficient from the table, and then we calculate the reference area, which is used to calculate the drag acting on the object, which is in the next equation. Similar to the one on the left, the calculations on the right are the same, just with different values of humidity. From the results obtained, the difference in time taken in the two experiments doesn't really differ that much. From these data, a calculation can be done, resulting in drag acting on the cube or the falling object. The drag acting on the object in high humidity is lower compared to when the humidity is lower, although the difference in value is relatively small. Theoretically, the higher the humidity, the lower the density, and the lower the drag acting on the falling object. In this experiment, this phenomena can hardly be seen, although the results somewhat supports this statement. The difference is so little that it might be considered negligible. In a bigger model, a bigger version of the experiment, a bigger difference and a more significant result might be met. Upgrades that can be done on the apparatus includes increasing the drop height and distance between the beams, installing a dehumidifier to further lower the humidity, or maybe change the dropped object and increase the scale of the apparatus. Thank you for listening to my presentation.